Here's some basic guidance you should keep in mind when designing repositories. First, a repository should have the illusion of a collection of a specific type of object. You'll be adding the objects to the collection, removing them, and retrieving objects from the collection. But that it is an illusion of a collection is important to keep in mind. When you interact with a repository, these are the types of methods you'll be calling: add, remove, and retrieve. Your calling code doesn't care how the repository performs those actions. So in the repository, you might have code that responds to a retrieve method, goes out to a database and gets data. But it could be getting data that's already in memory, or it might be grabbing data from a text file in your computer.
Another important recommendation for repositories is to set up access through a well-known global interface. That way, developers that need to interact with the repository will be familiar with a common pattern for using it. Here's a simple repository interface that we're using in our solution. Our repositories implement it directly. Depending on the size and complexity of your software, you may have a few layers of interfaces. For example, if you anticipate having a number of repositories for a schedule aggregate used in different bounded contexts, you might want an iSchedule repository interface that not only implements the lower level interface, but defines some other methods or properties that every schedule repository is required to have, regardless of the bounded context it might reside in. Because a repository acts like a collection, you'll want methods to add and remove objects to encapsulate the underlying data insertion and deletion operations. We've got these defined in our iRepository. It is up to each concrete implementation to define how add and remove will actually work.
While iRepository covers the least common denominators for all repositories, don't hesitate to provide methods in your repository classes that select objects based on certain criteria. These should return fully instantiated objects that match the criteria. For example, in our schedule repository, we know that we'll frequently want to return a schedule containing appointments for a particular date. So why not just make that a method in the repository to make it easy for developers working with the repository to get that particular schedule and set of appointments? So with this getScheduleAppointmentsForDate method, we can control how the query is executed. In our case, we're using Entity Framework for our data access. So we've put our best Entity Framework expert on this task.
Yeah, that wasn't me.
So now everyone using the repository can benefit from the expertise of that person, me in this case, rather than having to figure out the best way to write that logic. We're also avoiding the possibility of having multiple randomly written methods throughout the application to perform this particular query.
In addition to these specific tips for implementing repositories, you should also keep in mind these more overarching tips. First, be sure to provide repositories only for aggregate routes that require direct access. And next, keep the clients focused on the model while delegating all of the object storage and access concerns to the repositories. Repositories can add a number of benefits to our application. First of all, they provide a common abstraction for all of our persistence concerns, which provides a means for clients to very simply obtain model objects and to manage their lifecycle. They also promote separation of concerns. The domain logic and the user interface can both vary independently from the data and the backend data source that is used by the application.
The public interface of a repository very clearly communicates our design decisions. Only certain objects should be accessed directly, so repositories provide and control this access. Another important benefit is that repositories make it easier to test our code. They reduce tight coupling to external resources like database, which would normally make unit testing difficult. Having repositories separate from client code and domain logic means that we can easily make improvements to optimize data access for this application. Tuning for performance, adding caching behavior, etc. is all much easier and safer when the code for data access is all encapsulated in one or more well-known classes. And we have, in fact, gone through a number of refactors with the schedule repository where we fine-tuned the querying and some other logic that's within there.
Remember, your client code can be ignorant of the implementation of your repositories.
But developers cannot.
It's important that developers understand how your specific repository is implemented. Otherwise, they can run into a number of different problems.
So we're talking about not just the developers who are implementing the repository, but also the developers who are using the repository.
So some of the common repository problems that someone working with a repository might encounter are n+1 query errors. This is where, in order to display a list of rows from the database, you end up calling one query to get the list, and then a number of queries equal to the count of that list to fetch each item individually.
Another one that I see a lot is when people are fetching related data with Entity Framework. They're either using eager loading or lazy loading. And especially with lazy loading, there's a lot of developers who don't really know what to expect from it. And just because it's easy and it just works, they use it and then run into all kinds of problems because of it.
And depending on how your data is structured, sometimes if you're trying to fetch just one or two properties that are represented in a particular column in a data table, you might end up fetching more data than required if you pull back the entire row, which might include dozens of columns and a lot of actual data there. So these are things that knowing how your underlying data is persisted and how your repository is implemented, how those things work, can make a huge difference in your application.